Lab program 2. It is to design and develop a C program that accepts three coefficients a, b, and c of a quadratic equation ax square plus bx plus c is equal to 0 as input, and compute all possible roots and print the possible roots for a given set of coefficients. Also, print the message in case of zero valued coefficients. Yeah, the approach to solve this problem. So we know that the quadratic equation is of the form ax square plus bx plus c is equal to 0. In the equation, a, b, and c are the coefficients. And the roots of this quadratic equation is given by minus b plus square root of b square minus 4ac divided by 2a. That's one of the root. The other root will be minus b minus square root of b square minus 4ac by 2a. So that is how the roots of quadratic equations is calculated. Then we have a term, that is b square minus 4ac, the term which is under the square root. It is called as the discriminant. So depending upon the value of the discriminant, we are telling what type of roots are we going to get. Okay, so if the discriminant, that is b square minus 4ac, is 0, then the roots that we get will be of real and equal. Suppose the discriminant value is a positive value, that is greater than 0, then the roots will be real and distinct. Otherwise, that is, if the discriminant is a negative value, that is less than 0, then the type of roots that we get will be of the type complex. So that is why we need to calculate the discriminant to decide what type of roots we will be getting. Yeah, here is the program to find the roots of a quadratic equation. We are including two header files, stdio.h, that is standard input output header file, and math.h, that is mathematical. If we are going to use any built-in mathematical functions, we need to include math.h header file in our program. Then in our local declaration, we have few variables that we are declaring, which is of the type float, a, b, c, which are the coefficients of the quadratic equation. Then we need to find two roots, so r1 and r2 representing the two roots. Then d for discriminant, because that is the one which will decide, which will tell us what type of roots are we going to get. Then we need to have a real part and imaginary part for the complex type of roots. So that's what is the R part and I part are for. Then we have a message to be printed on the screen that we are going to do using a formatted output function, that is printf, asking the user to enter the non-zero coefficient values of a, b, and c. Then to read those non-zero coefficient values for a, b, and c, we are using a input function, that is scanf, and we have to note that a, b, c are of the type float, so we need to use %f format control string, and we have three variables, three values to be read, so three format control strings. Once we get the values of a, b, and c, the next thing to do is calculate the value of d, so that we will know what type of roots. So d is equal to, as said before, it is the term that is there inside the square root. So here we have the square root. So b square minus 4ac is the discriminant. So d is equal to b square minus 4ac. We have used b into b minus 4 into a into c, or you could have made use of power function to take the b square. So POW b comma 2 would also do the b square for you. Then once we have the value of discriminant calculated, depending upon the value of d, that is three possible cases. If d is 0, what type of roots? When d is greater than 0, what type of roots? When d is less than 0, what type of roots, right? So to do this, there is a decision making based on some condition. So to do that, we are using a multi-way selection statement and else if ladder, wherein first we have the if statement, keyword if followed by the condition. So we are checking whether d is equal to 0. If the value of d is 0, we know that the roots are real and equal, and then calculate those roots, right? Once we know that the roots are real and equal, we also know that the formula to calculate those roots, right? Real and equal, both the roots should be equal. So what is that value of those roots? Both the roots will have the value minus b by 2a. Let's see how we are getting that. So this term became 0, correct? D is 0, so the whole term is 0. We are left with only minus b by 2a, right? That is why both our roots will have the value of minus b by 2a. That is what we are having it here. R1 is equal to minus b by 2a. R2 should also have minus b by 2a. Instead of calculating again, solving an expression again, we are directly assigning that value to R2, assigning R1 to R2 using an operator, assignment operator. So equal to here is an assignment operator. Once we have calculated both of those roots, we are displaying those roots using a printf statement. Printf root 1 is equal to, the value of R1 will be substituted there, and root 2 is equal to R2, correct? Two variables, two format control string in your printf statement. Suppose d is not equal to 0. If this condition fails, then it will go to the else if statement, wherein we will be checking another condition. That is, else if d greater than 0, if d is a positive value, what happens? If d is a positive value, we know that the roots are real and distinct, right? Those are not equal, they are distinct. So we need to calculate both of those roots R1 and R2. R1 will be equal to minus b plus square root of d divided by 2a. Other root will be minus b minus square root of d divided by 2a. How did we arrive at this? See here, this value is greater than 0. See, greater than 0, so the roots are real and distinct. So our first root will be minus b. Instead of plus sign minus, we will take plus for one of the roots, minus for the other root. So minus b plus square root of d divided by 2a as the first root, minus b minus square root of d divided by 2a as the second root. That's how we get the roots R1 and R2 whenever the roots are real and distinct. Then once we have got the value of R1 and R2, we just have to display those roots. To display, we are using the output function printf, and then we display root 1 is equal to R1, root 2 is equal to R2. When this condition also fails, then it goes to the else. If d is not 0, if d is not greater than 0, that means d has to be less than 0. So it has to go to the else whenever d is a negative value. So if d is a negative value, we get the imaginary roots. So our imaginary numbers will be of the form a plus ib, right? Where a is a real part, b is a imaginary part. So to calculate that, here we are calculating r part and I part instead of directly calculating r1 and r2. So r part will be minus b by 2a, I part will be square root of d divided by 2a. Here we are taking FABS of d because d is a negative. To convert the negative value to positive, we are using an absolute function. So that is why FABS. It is also a built-in math function. That is why we have included the header file as well. So once you get the real part and imaginary part, we are displaying root 1 and root 2. So root 1 will be real part plus I imaginary part. Root 2 will be real part minus I imaginary part, right? So that's how we are calculating roots of a quadratic equation. Then end of the program, return 0. Let's look at a sample output here. As we had a message to be displayed on the screen for the user, asking the user to enter the non-zero coefficient values of a, b, and c. If the user enters 1, 2, and 1, that means a is equal to 1, b is equal to 2, c is equal to 1. Then on calculating d, we get to know that the roots are real and equal, and we calculate the roots and displaying those roots, r1 and root 1 and root 2. See, both should be equal. Okay. Let's look at the tracing of the same sample. A is equal to 1, B is equal to 2, C is equal to 1. Once we read the values from the user, the first thing that needs to be done is calculate the value of discriminant. D is equal to B square minus 4AC. B is 2, so 2 square minus 4 into A into C, which is equal to 0. So D is 0. So when we check the condition, see, since D is equal to 0, if statement will be executed because we have a condition with if is if D is equal to 0. So there we got D as 0. So these 4 statements should be executed. See, if statement will be executed, it displays the message, the roots are real and equal, and then calculate those roots. So R1 is equal to minus B by 2A. So B is 2 here. So minus 2 divided by 2 into 1. A is 1. We get minus 1. Then R2 is equal to R1 because both the roots are equal. So R2 also will have the value minus 1. Correct? After you execute those statements, we come out of the if statement. We will not be executing else if or else because it is a multi-way selection statement. Among those, you execute only some set of statements depending upon the condition. That's how our else if ladder works. After the multi-way selection statement, we just have to display R1 and R2. That's how our values of root 1 and root 2 gets printed on the screen. This is how the program works.